A homogeneous mixture, also known as solutions, is a mixture that is the same or uniform throughout. Means that any given sample of the mixture will have the same composition. Solutions are homogeneous mixture containing two or more substances. For example, coffee. Coffee is a mixture of filtered coffee grounds and water. When the two substances mix together, we get a solution or a homogeneous mixture. Now, if you look at the solution, it has a one appearance only because the components are evenly distributed. A solution is made up of solute and solvent. The substance to be dissolved is called the solute. The one that is doing the dissolving or the dissolving medium is called the solvent. Once a solution is formed, it is impossible to distinguish the solute from the solvent, as everything is uniformly distributed. A solution can exist as a solid, liquid, or gas, depending on the state of the solvent. The following given examples are the combinations of a solution. Air is an example of gaseous solution or gas dissolves in gas. It is composed of various gases such as oxygen and nitrogen. Carbonated water is an example of gas to liquid solution, with carbon dioxide as the solute and water as the solvent. An example of liquid to liquid solutions is vinegar, a mixture of acetic acid and water. Ocean water or salt water is an example of a solid to liquid solution, with sodium chloride as the dissolved substance and water as the dissolver. Other solid to liquid solutions include toothpaste, sweetened tea, or coffee. Liquid to solid solutions is dental amalgam or dental fillings, with mercury as the solute and silver as the solvent. At last, steel is an example of a solid to solid solution, with carbon as the solute and iron as the solvent. Other solid to solid solutions include bronze, brass, and gold. Depending upon the dissolution of the solute and the solvent, solutions can be categorized into unsaturated, saturated, and supersaturated solution. Unsaturated solution is at less than the limit of solubility. It completely dissolves, leaving no remaining substances. A saturated solution is one in which the solvent has reached its solubility limit. The solvent is unable to dissolve all of the solute, while the undissolved substances settle to the bottom. A supersaturated solution is created when any solute to a solvent has reached its limit of solubility. It contains more undissolved solids than the saturated solution because of its tendency to crystallize and precipitate.
Factors affecting solubility. But first, let us define what is a solubility. Solubility is defined as the maximum amount of a substance that will dissolve in a given amount of a solvent at a specified temperature. So, number one is temperature. When the temperature increases, the solubility also increases. In exceptions, the temperature increases and the gas decreases. So, how the solubility happens in a temperature? For example, there is an iced coffee and a hot coffee. In hot coffee, the solid particles or a lot of sugar can dissolve into a hot coffee, while in iced coffee, less solid particles can be dissolved. Even if you stir it at a certain point, you can't dissolve the sugar. It is just going to the bottom of the glass and cannot be dissolved. This means that at the higher temperature, more solute can dissolve. As the temperature increases, the solubility increases as well. On the other side, in iced coffee, the less temperature, the less solute can dissolve. When the temperature decreases, the solubility does. Next is how temperature affects the solubility of gases. In gases, it is opposite of what we see in solids. In gases, when the temperature of the solution increases, the solubility decreases. As the temperature increases, the solubility of gas decreases. It also means as we decrease the temperature, the solubility increases. The higher temperature, less gas can be dissolved, and the lower temperature, more gas can dissolve. So, number two is pressure. Pressure has no effect on solubility of liquids and solids, in exceptions, as the pressure increases, the gas decreases.
For example, a soda. Soda would provide a nice illustration of this relationship. The carbonation process involves exposing the soda to a relatively high pressure of carbon dioxide gas, and then sealing the soda container, thus saturating the soda with carbon dioxide at this pressure. When the soda container is open, a familiar hiss is heard as the carbon dioxide gas pressure is released, and some of the dissolved carbon dioxide is typically seen leaving solution in the form of small bubbles. Third is polarity. Polarity plays an important role in solubility. A polar solute dissolves in a polar solvent, whereas a non-polar solute only dissolves in a non-polar solvent. If we put a polar solute in a non-polar solvent, it will not dissolve. For example, to remove paint from clothes, we don't use water. We use an organic solvent like acetone or petrol. Paint is a non-polar, and to dissolve it, we need also a non-polar solvent like acetone. Chemists use the aphorism like dissolves like to describe polarity because the solute and the solvent must have the same polarity in order to be miscible.
So last is the particle size. Why larger particles dissolve faster than smaller particles? Let's take a look on this example. Let's pour a 250 ml of water into glass. In glass number 1, let's add 1 tablespoon of rock salt. And in glass number 2, let's add an iodized salt and stir it, the solution or the water in both glass. As you can see, the rock salt was completely dissolved while iodized salt doesn't, because it is larger particles, has a great surface area, and there can be more contact between the particles of solute and solvent. And that's are the factors affecting solubility.